We are now going to solve geometry problems. And geometry problems are those that are solved using formulas from geometry. So a couple of definitions just to make sure you're aware of right now. If we have two lines and they're separated by 90 degrees, so one's going straight up, one's going straight across, or you can angle it so that was the case, this is called a right angle. It's also possible, so that I have this point here and a line going up and a line going to the right. It's possible that you have them going exactly away from each other. If this is the case, we have a straight angle because it forms a straight line, and it actually makes up a total of 180 degrees. Now we have things between these, and so if we have this point and we have another line coming off here, these two lines, notice they're smaller than the 90, so that makes them acute angles. If it's bigger than 90 but less than 180, it's called an obtuse angle. Likewise, we have some triangles. Some specific definitions that you need. If we have a triangle that has a right angle between two of them, then it's called a right triangle. No matter how you angle that around, no matter what it's shaped like, as long as you get a 90 degree out at in one corner, it is in fact a right triangle. There's also a triangle where you have even sides. This is called an isosceles triangle. Isosceles. And it means that they have the same side. This side and this side are the same length. It also means that these two angles, called the base angles, are the same. And then we have up here what we call the vertex angle. The last one is an equilateral triangle where all three sides are actually the same. So this mark shows that they're all the same. So this would be like 12 feet, 12 feet, and 12 feet. In this case, all of the angles are also the same, and the angles are all 60-degree angles. Because another definition about triangles that you need to make sure of is that if you sum up the three angles, angle A plus angle B plus angle C, always adds up to 180 degrees. If it does, you've got a triangle. So those are our definitions. Now let's actually use these definitions to solve a problem. The flag of Guyana, shown below, a republic on the northern coast of South America, is one isosceles triangle, this red one, on top of the yellow, superimposed over on another, on top of a field of green, like shown. The measure of the base angles of the larger one is 14 degrees more than the smaller one. Remember, because it says they are isosceles triangles, we know that this angle is the same as this angle because they're referred to as the base angles. And the measure of the vertex angle of the larger one is 34 degrees. Find the measure of each base angle of the smaller triangle. Well, we can't do anything with the smaller one because we don't know what this is yet. So we know that x plus something, y, adds up to 180, but there's no other information there. However, on our larger isosceles, which has an angle 14 more than the other one, we have our first angle, x plus 14, plus our second angle, x plus 14, plus our combination 34, and that's got to add up to 180. So we can use this to figure out what x is. Well, we don't need the parentheses. We can drop those. So now we combine. X plus x is 2x. 14 plus 34. 28. 22 plus 30 is 62. Equals 180. Let's subtract 62 from both sides. So 2x equals 118. Divide by 2. We get x is 59. So we now know that our smaller one has a 59 and a 59, which answers the question. To check our answer, we need to make sure that the larger one adds up to 180 still. So we take 59 plus 14 plus 59 plus 14 plus 34. Well, 59 plus 14 is 73, so that's my larger one. This one's 73, and this one's 73. So 73 plus 34, does that add up to 180? Well, 73 plus 73 is 146 plus 34. Sure enough, 146 plus 134 is 180. Since both sides work, our answer checks out, and we know that our smaller isosceles triangle has a base angle of 59.